Guys, so this is another style of the problem from the Pythagorean theorem challenge that I thought you might have trouble with. I know that when I read it, I had a little bit of trouble the first time. So I looked at it and it said, it looks pretty simple, right? Carol bikes 1 kilometer east, 4 kilometers north, and 5 kilometers east. So like the directions, the information you're given, it's not particularly complicated, but we want to know how far Carol is from her starting position. So I said, okay, well, I'll draw a picture. So I said, okay, here's where Carol started. And she goes 1 kilometer east. And I'm just going to do like a little, right, compass rose, north, south. Oops, that's definitely not south. You guys are south, east, and west. So north is going to be up, east is going to be the right, south would be down, and west is to the left. It doesn't really matter which direction you go, but since that's what we're used to, that's what I'm going to use. So, right, she goes 1 kilometer east. And then she's going to go 4 kilometers north. And then she's going to go 5 kilometers east again. So if I wanted to know where she was from her starting point, right? She started here, she ended here. It's this distance. That's what we want to know. How long is that red line? So this is how I drew my picture first. And I went, how am I going to figure this out, right? I could use the Pythagorean theorem because I've got a couple of tiny little right triangles, like this little guy down here and the big guy up there, but I'd need to know this point, right? Where does this, why would I do that? That's weird. Where's that cut off? Because I need to know the height of this triangle and the height of the other triangle, right? So I thought, well, I don't know that. So how else could I arrange this picture so that I have all of the information that I need? So here's the plan. Here's the other thought, right? Her starting point is still here. Her ending point is still here. So instead of following her path, what if I just went the whole way east? And then the whole way north. Oops. Probably should go over more. There we go. Right? Then I don't have multiple triangles. I just have the one green triangle that I have to deal with. Now, the question then is, how far east did she travel in total? Well, in total, right, she traveled 1 kilometer here, and then another 5 kilometers here. So she traveled 6 kilometers in total east. And then how far north did she travel? Well, from here all the way up to here, it's still 4 kilometers. We don't have to worry about that break. And so we want to know how far is she from her original starting point. So we got this nice green triangle, and we can use the Pythagorean theorem on it. A squared plus b squared equals c squared. Right, remember C is always our hypotenuse, and then it doesn't matter which ones you label A and which ones you label B. As long as you get C right, the other ones will be right too. Okay, so I said A was 6 kilometers, B was 4 kilometers, and C is some unknown number of kilometers. So 6 squared is 36, 4 squared is 16, that's 12, 4, 5, so that's 52. And I know the square root of 52 as a simplified version, but unfortunately I don't know what it is off the top of my head for a decimal. Now I know it's between 49, which is 7 squared, and 64, which is 8 squared, and it's definitely closer to 49, so it's definitely going to be closer to 7, and it is. When I use my calculator, I get about 7.211, somewhere around there. So it asked me to round my answer to the nearest tenth of a kilometer. So to the nearest tenth of a kilometer, that'd be about 7.2 kilometers. Okay. So I hope showing you how I thought about this picture is helpful for you. I know that's probably like once you get the triangle, I think the actual solution's not terribly difficult, something pretty straightforward, something you guys have done. It's just converting this picture into that picture. That's the tricky part. But now you've seen it, so hopefully when you see a problem like that, you can do it again. Or once you've seen that one train of thought, you can see it again. Hope this helps. Bye.